Hello everyone, I am Prasad from Structural Guide. Today we are going to discuss about why concrete needs reinforcement. As you know, when we build the structures, we usually provide the reinforcement in the reinforced concrete structures. But there are structures like gravity structures where we don't provide the reinforcement. So what's the difference between these two structures? Why we need reinforcement in structures? Where we need the reinforcement structures, all those much more will be discussed today in this video. So wait till end of this video, we'll be knowing many facts on requirement of the reinforcement in structure. Right, let's begin with the concrete. What is the concrete? Now, as we all know, cement, water and aggregate are the three main components of a concrete structure, or the concrete. Actually, concrete structure have a different meaning, but when it comes to concrete, these three are the main component. Cement and the water reaction made the concrete. This process is called hydration. So during this hydration process, this hardened material is created. As an additive to this material, we use sand and coarse aggregate, right? We add coarse aggregate and sand as additive to this mixture, so we get the considerable volume. In addition to that, we add admixtures and there are some other additives also. So but basically when we discuss the concrete, we have aggregate, cement, sand. There are mainly two types of structures. Those are gravity structures and the reinforced concrete structures. And also there are structures in between like semi-gravity. That is between the reinforced concrete structures and the mass concrete structures. So when it comes to the gravity structures or the mass concrete structures, we don't provide the reinforcement. So certain retaining wall like this. So this is a retaining wall. This is a full mass concrete structure where we don't provide the reinforcements. And there are other types of structures that may be thinner than this particular structure. It has a considerably thinner section, so its behavior governs by the forces, that is bending moment, shear forces, torsion, like that. In these structures, actually the behavior is governed by the stresses, because when it comes to bending moment, we are not going to discuss the bending moment in these type of structures, but we discuss mostly stresses. But when it comes to the overturning and sliding, we definitely have to consider that. Other than that, for the design, we don't consider. The ultimate design, we don't consider the bending and shear forces and all that in most of the time, not all cases. Right. Let me discuss about the properties of the concrete. Now, as we know, concrete is a very strong material in compression. But when it comes to the tension, it is not so. That's you might be aware, no? Right. So you can see this is let's say it's a cross section of the column. So when you have axial load on a column like this, it can bear very high axial load. So how do you recognize this? Right. When it comes to the concrete, we specify concrete as from the grade. Say grade 25 concrete, C30, grade 30 concrete. This means the compressive strength of the concrete, or the characteristic compressive strength of the concrete is 25 newtons per millimeter square. Here, when it comes to grade 30, characteristic compressive strength of the concrete is 30. Right. Now, what is the tensile strength of this concrete? What if we apply a tensile force into this element like this? It will get cracked at certain stress. So what is that stress? Usually the tensile strength of the concrete is about 10%, right? 10% of the compressive strength. It is 10% about the compressive strength. This is a general no, but there are equations in the standard light Euro code to calculate the tensile strength of the concrete. So for this discussion, let's say the tensile strength of the concrete as 10%. In that case, so in this grade 25 concrete, we get 2.5 newtons per millimeter square tensile strength because it's 10%, so it has to be divided by 10. Right here, it's about 3 newtons per millimeter square. Right, so you see very small value when compared to the compression strength. Tensile strength is very small. So this is 30, this is 3. You see, very small. So you can now understand when it comes to the concrete, its compressive strength is very high and significant, but its tensile strength is comparatively very small. So this is the main reason we has to have the reinforcement. Right, let's see how that happens. Let's take a simple beam. Let me draw it here. Right, this is a simple beam. So you have a support here. What if we apply load on this beam? This beam will deflect like this, right? This beam will deflect like this. It has a certain deflection here. So this is the deflection of the beams, right? So when it deflected or when loads applied, you can see the bottom you have a tension. In the top you have a compression. So this part will be compressed, but this part will be in tension. So you can see there is two parts, two segments, two areas in an element subject to the bending. That is, so in a section, when you take a section like this, in a beam, this area is in compression, this area is in tension. This area is compression, this area is in tension. So as we discussed previously, tensile strength of the concrete is very small compared to the compressive strength. Therefore, in this zone, when the stresses are applied, we have to have reinforcement. That is the reason we provide the reinforcement in a structural members. So there are certain areas where the tensile strengths are developed. So in those areas, we have to provide the reinforcement. So that's the cause of providing the reinforcement. Right. Is that so? No, it's not always the case. That's a one thing. But when it comes to the column, that is not so. This a column is axial loaded element. Right? You know that. Right. This is a column. This is axial loaded element. So you might have wondering why we need the column reinforcement there. You see now concrete has, so say grade 25 concrete, so it has this much of stress, right? Now when it comes to the columns, now you have to have an axial load. It has to bear the axial load applied from the superstructure structure. Now when it comes to the columns, we can't increase the columns as usual or as you wish, because it will be a very high cost. So what we do is we consider the combination of the concrete and the reinforcement for the column, right? Combination of these two generate the column axial load. This N is the column axial capacity. It's come with the concrete and it's come with the reinforcement. When you have a links in the column, so it's confined the column reinforcement, then it has a axial load carrying capacity. Therefore, we can consider the column axial capacity and the column compression capacity. So this is the why we provide the reinforcement in the columns. In addition to that, there are many other reasons we need to have reinforcement in the columns, but basically column reinforcement has a certain impact on its capacity. So concrete compressive strength together with the compressive stress developed by the reinforcement carry the axial load of a column. The similar thing will be applied for the beams as well. Now when you have a beam like this, so as we discuss in certain area or this bottom part, we need the reinforcement, right? So this part we have a tension, right? Compression, sorry, we have a compression stress group like this, then we have a tension reinforcement there. But this also have a certain limit. Now this stress we can't exceed by a certain limit. When it comes to the BS, this strain we have to keep around 0.0035. You can't increase this strain in a reinforced concrete beam or reinforced concrete structures. But when you increase the loading, and it will, if it's continue increasing, this will be this will reach by the concrete. So we can't allow this to reach, because if now we know the concrete fail by crushing. When you have a reinforcement does not fail suddenly. It yields strains, it allowed to crack to form, then and only it fails. But when it comes to the concrete, it crush and fail, so it's a sudden failure. Therefore we shall not allow the reinforced concrete to reach its strength or its capacity. Therefore what we do is, when we do the designs, we always try to maintain the concrete strength below this value. Therefore what we do is, when the reinforcement or when the concrete strain increases, we provide the reinforcement. Those reinforcement are called the compression reinforcement. This bottom reinforcement, when you have a say tension here, compression there, bottom reinforcement or this tension reinforcement, we can call as a tension reinforcement. Then this top reinforcement where we provide at the compression zone are called the compression reinforcement. Okay, these are compression reinforcement. So there are two type of the reinforcement now, as we understood. So tension and compression reinforcement in a structure elements, in the beam also in the column we provide the reinforcement to carry the compression. So with that I think you are well aware, well, now it's very clear to you why we need to provide the reinforcement in a reinforced concrete structures together with the concrete. So other than that, we are going to discuss about the alternatives for the reinforcement. Do we have alternatives? Yes, we do have alternatives for the reinforcements. What are those? Usually at the present day, we are not replacing the reinforcement completely in a reinforced concrete structures. What we do is, we use combination of reinforcement or any other alternative, or we use only the reinforcement, because still technology has to come and technology to be developed to fully replace the reinforcement in structures. But when it comes to the industrial floors or floor slabs that are rested on the ground, but when there are tensile stresses develop due to the applied loads, then those industrial floors and those similar structures, and in certain slabs, construction slabs, we provide the alternative material like fibers, fiber reinforcements, and different type of other fiber materials can be used for the slabs, and also it is being used for the slabs but not for the beams present day. Mostly this will be used in the beams and columns as well in future, by replacing of the column reinforcement, or by using them as a combination in the sense reinforcement together with these alternative materials, so that we can reduce the usage of the reinforcement. And also we might be able to reduce the reinforcement concrete element sizes as well with that. So with that, I'm going to end the today discussions. We today discuss about why concrete need reinforcement. So I think it's now very clear to you requirement of having reinforcement in a structure, where we need, why we has to provide the reinforcement in a reinforcement concrete structure, and where we have to provide the reinforcement in reinforced concrete structures. With that, we conclude the today's video. Let's meet again from new video. Thank you very much for watching our videos.